Students, the topic for the day is array representation of stacks, and we look at even operations on a stack. This is the outline. We want to discuss what are the lecture outcomes, the actual topic, representation of stacks, and what are the operations possible on stack. Next, the summary, and we'll revise the lecture outcomes once again, and we'll look at things like problems and further reading. So, lecture outcomes after completion of this lecture, students will be able to understand the basics of stack, and also how do we apply these stacks in various other applications. So, stack is a linear data structure where the insertion of deletion of elements in a stack happens only from one end. So the one and only end we call as a top of the stack. So that's why stack is called last in, first out structure, or you can say LIFO, where the last element inserted into the stack is the first element deleted from the stacks. So one important thing we need to remember is stacks can be implemented using either arrays or maybe linked list. So in this unit 2, we'll only look at implementation of stacks using arrays, and unit 3, we will look at implementation of stacks using a linked list. And every stack has a variable called top. So you can see this is an example of stack where we had inserted the first value as a 10. Next, we had inserted 45, 12, 16, 35, and 50. So last value inserted is 50. And if I want to delete a value, I need to delete is only the last value inserted, which is 50. That's why we call it as a last in, first out LIFO. Because last value inserted is 50, and that will the first value deleted if you want to pop or delete a value from the stack. And the top is a variable which contains index of topmost value in the stack, or you can say the last value in the stack. So here the topmost value is 50. The lastly inserted is 50. Its index is stored in top. And maximum number of values a stack can store it depends on the array size. If array size is max, maybe max can be 10, then only 10 values can be inserted in a stack. So these are so inserting a value or deleting a value from the stack, technically we call it as push or pop operation. Push is a push we call as inserting a value into stack, and pop we call as deleting a value from the stack. So here we have an empty stack. We assume we have an empty stack, that is a stack which doesn't contain any values at the moment. And next we want to insert a value, or we can say push a value into the stack. So here you can see value 1 is pushed into the stack. Next you can see in next attempt we had pushed the second value 2 into the stack. Next we had inserted third value into the stack, and so we have 3 values are available in the stack. And if you want to remove one value from the stack, so what is the value we will remove from the stack? So we will remove the topmost value 3, we will remove. So removing a value from the stack we call as a pop operation. So you can see 3 is we are removing, popping from the stack, and we will the stack is left with only 2 values, 1 and 2. And for example, if you take this stack, the top for these 3 values, the indexes, array indexes will be, this will be something like 0, index of 1 will be 0, index of 2 will be 1, and index of 3 will be 2. That is index 0, index 1, index 2. So at these indexes, the values are stored. So as the topmost value is 3, the top variable will contain index of 3, which is 2. So top will contain 2, which is the index of the 3 value. So as we discussed, the basic operation push, pop, peek. We've also seen what are all these 3, which is nothing but adding a value or inserting a value into stack. Pop is removing a value from the stack. Peek operation is returning the topmost value, the stack. So this is a demonstration with a image how a push operation works if we implement stack using an array. So you can see this is something like a stack, and we also assume we can assume this one has an array also, where these are the indexes 0, 1, 2, 3, 4, 5, 6, and until 9. So obviously we have 10 memory locations. We can store 10 values, and every memory location has indexes like 0, 1, 2 until 9. And you can see here the rectangle boxes or in the memory locations, we had stored values. So these are the values 1, 2, 3, 4, 5. These are the values. Just a moment. So here in this array, we want to insert, that is, we had inserted these values 1, 2, 3, 4, 5, and the topmost value or the last value in the stack is 5, and its index we have is 4. So the top variable, what is the index the top variable will contain? So it contains the index of 5, which is 4. So in top variable we store 4. For example, if you want to insert another value, for example, 70 I want to insert here. Then if I insert 70 here, what top variable will contain? It will contain index of 70, which is 5. Top now will contain 5. So here you can see the next to this one. If I want to insert another value, maybe 70 or it can be a 6, the top will contain. So whenever you go on inserting a value, that in top will be incremented every time. For every insertion, top will be incremented. So when I insert another value here, maybe 80, then top will contain 6. How do we get the 6? It's a top plus plus. Or we can see index of 80 is also 6, which is stored in top. Similarly, pop operation, if you want to delete a value from the stack, then we need to decrement top. So for example, I want to delete a value 5. So at the moment, the 5 is a value and its index is stored in top, which is 4. But if I delete 5, then the next topmost value is 4. Its index 3 need to be stored in top. How do we get this 3 in top? We will do top minus minus. So obviously we get the index of this 4, which is 3. And remember, if there are no elements in the stack, the stack is empty without any values, then top will contain -1. So whenever you want to insert a value or push, to do push operation, the condition you need to check is whether the stack is empty, that is, if the stack is full or not. How do you check if stack is full? Is a condition. Top is equal to max minus 1. If top is called max minus 1, so max is nothing but it's an array size. So top is equal to max minus 1, it means the stack is full and you cannot push another value into the stack. And if top is equal to maybe minus 1, then it means you cannot, that stack is empty and you cannot delete a value from the stack. So if stack is empty and you want to do a deletion, we call it as an underflow. And if a stack is full and you want to insert a value or push a value, then overflow. We call it as an overflow condition. So these are the function for the push operation, where you will check whether the stack is full. If it is full, we print that stack is overflow. And if it is not full, the else part, we can insert the value. So for inserting a value or pushing a value to the stack, we will increment the index in top variable. And at that index, st of top, at that index, we will store the actual value. For example, previous top contains index 5, we will increment it, it becomes 6, then the st of 6, the sixth index, will store a value like 40. And this is a pop operation where we want to delete or remove a value from the stack. So the condition to check before removing a value is if there are no elements in the stack, we cannot remove a value or pop a value. First, we need to check whether stack is empty. If it is empty, so you can see with this condition, we can check if top is equal to minus 1, then stack is empty. If it is empty, we call it as a stack is underflow. Is we cannot delete a value or pop a value if it is empty. If it is not empty, then we will store the topmost value into a variable val, and then we will decrement the index in the top variable. So that it points to second topmost value. And next we return the previous topmost value. So it means that we had removed the topmost value, and now the top is pointing to the second topmost value as we had decremented its index. And the peak, we already know it returns the topmost value. So here you can see it returns the topmost value. And before that, we will check whether stack is empty or not with this condition. So this is a program where there are all the functions included: push operation, pop, peek, and display operations. And here you can see in this, because we want to show something like a menu where with multiple serial numbers, like this is a menu for displaying menu to all the printf statements. So you can see press 1 for push operation, press 2 for pop operation, press 3 for peek, press 4 for display, 5 for exit. So this is something like a game, right? So this menu need to be printed in a there is multiple times. It need to be printed again and again, something like in an infinite loop until you exit, until you enter 5 and exit. So you will display this menu, and next you ask the user to enter your option. So he may enter either 1, 2, 3, 4, or 5. Any one number he will enter. So that option will be stored in this option variable. And this option variable you will pass as a parameter to the switch case, switch, and based on the option you selected, if the option is 1, then case 1 is executed. If option is 2, case 2 is executed. If option is 3, case 3 is executed. If option is 4, case 4 is executed. Okay, so if it is case 1, we will execute push function. Case 2, pop function. Case 3, pick function. And case 4, display. And you can include case 5 for the exit. So you can see we had kept the condition here itself. So you can keep another case 5 and you can write exit also, or other one is while option not equal to 5. This is another condition we can keep. So while option not equal to 5, until you do not enter 5, it keep on displaying this menu, and you can do each time you can do push operation or pop operation or pick, display, and so on until you enter 5 and exit the program. So in each iteration, you can see it runs from this is a do while do starts from here, and at the end we have a while. In this do while loop, each time it displays the menu, and based on your option, the appropriate function, whether push or pop or peek or display, all this will be executed. And finally, when you enter 5 option, you will exit from the do while. And here the main function ends. Okay, so these are all the definitions of push function outside the main written outside the main. So these are push function definition, these are pop function definition, display function definition, finally peek function. Okay, students, I hope you are clear with the concept of stack. So a revision of the lecture outcome, that is at the end, students are able to understand the stack and its various operations, the push and pop operations, and how they can be applied in various other applications. And in the summary, we can say like a stack is a data structure where data can be inserted or deleted only from one end, that is the top end. And the operations possible on the stack is push and pop operations. Yeah, thank you, students.